So alkenes are hydrocarbons. So hydrocarbons are compounds that have hydrogen and carbon only, which means there are no heteroatoms. Heteroatoms are elements such as oxygen, nitrogen, and sulfur. Now, so we have alkanes. This is methane. And we can have an alkene. This is methane, which is an alkane. And this is ethene, which is a ripening reagent, and it's an alkene. A ripening reagent is like a compound, a gas that's given off by bananas and tomatoes to turn like tomatoes from green to red. And this is an alkyne, and this is ethyne. Now let's talk about hybridization. So the way I do hybridization is I ask myself, what four groups are attached to the element? So when you're looking at that, you can see, so here's this carbon, and you have 1, 2, 3, 4 groups. So that is sp3 because the superscripts, which is that upper number, need to add to the group. So you can see 1 plus 3 is 4. And so this is how I do that. And when you're hybridizing, so if you remember from Gen Chem, you have an s orbital, which is sphere, and you have like the px, the py, and the pz, and these are like unhybridized p orbitals. And so if you need to make an sp3 orbital, then you're going to need one s, and then you're going to use all 3 orbitals. So there's nothing left. And this is going to have about 25% s, and it's going to have 75% p, because that wants to total up to 100%. Okay, so for alkenes, we have how many groups? We have to attach to that carbon. We have 1, 2, 3. So that's an sp2 because 2 plus 1 is 3. And then you can do the same thing with the other carbon, and you see that you have 1, 2, 3. So that's an sp2 bond. And so that requires 1s. We'll take the 1s here, and it requires 2 p's. So if you take this p and you take this p, you see that would be sp2. That's about 33% s and 66% p. That leaves you with an unhybridized p orbital. And so there is an unhybridized p orbital that's above and below the plane that has those 2 electrons in their orbital. And so just to be thorough here, an alkyne has 2 groups, 1, 2, so that's sp. You can do the same thing with the other carbon, and you have 1 and then 2, so that's sp-sp. So an sp-sp would have 1s and then 1p, so that would leave 2 unhybridized p orbitals, and that's 2 pi bonds for an alkyne. But our interest is the alkene.